So friction you are all familiar with. It opposes motion. If I want to move this desk across the, yes I did, you're right. If I move this desk across the surface, well, then I'm going to come over and move that desk. Okay, put your feet up, pick your feet up. Okay. Say hi. Chris, you can move them back. Okay. When pushing, now you might have noticed I did a lot less force moving this desk than I did moving the desk with Caleb in it. No, but he's got more mass than the person sitting in this desk, for sure. All right. We have two kinds of friction that we work with. And you're all familiar with these conceptually. We have static friction, we have kinetic friction. Okay? This is not static in the sense of static electricity. This is static in the sense of unchanging, unmoving. We talk about systems sometimes as being static systems or dynamic systems. Something which is static is unchanging, unmoving. Dynamic is in motion. Static friction is the friction of an object that is at rest and that you're attempting to get moving. So, currently, I have this tape dispenser sitting on this lab desk. There's friction between the surface, but I don't know. Here's the interesting part. Okay, if I start to push on this, and I'm just barely touching it, I'm hardly pushing on it at all, there's static friction on it. As I increase the force that I am using, static friction increases. Increasing, increasing, and now I don't have any more static friction. Okay, let's run that with a spring scale. Wir haben ein spring scale. Und we need some mechanism with which to pull said object. Okay, so I've got my spring scale. I've got my little hook. Is it really annoying? Yes, I can hear that. Let's do this. We're going to max out that spring scale. We need a bigger spring scale. More newtons. Okay, perfect. So, right now I am exerting some amount of force on this tape dispenser, yet it is not moving. Debbie, can you read that spring scale? Yeah. Okay.
There we go, I can see it.
Okay, what's it say?
2, 3.
Okay, I'm going to increase the amount of force that I'm applying. What's it read now? 4.5, still not moving. Oh, there we go.
That was
Yeah, we're going to tear through the tape. Okay. As I increase the force that I'm exerting on that thing, until it moves, the force can keep increasing, and the static friction force is increasing. At the point when something starts to move, static friction disappears, and we're now in the realm of kinetic friction.
Wait. Kinetic friction increases.
Kinetic friction does not do the same thing.
Not kinetic, if static friction increases, then what makes it increase?
We're going to talk about that. That's the threshold where you overcome static friction. The force of static friction max. So, as long as we're not moving whatever it is, but we're still applying force, the static friction is equal to force applied. There went that. Then the tape pops and the paper clip goes flying through the air. So, have any of you ever attempted to push something to get it moving? And again, with this winter season upon us, perhaps some of you have had the experience of getting stuck someplace and trying to push a car out of something. Okay, now this is one that I feel quite okay with giving you homework in. So go someplace, get stuck, and push it out. Well, I think you should all go as a group, so you've got lots of people to push it out.
That makes sense.
Find a good snowbank someplace. Are you serious? Okay, so if you have been in that situation, actually I can probably be in that situation right now. So just stay right where you're at, both of you. Okay, I'm pushing. I'm not moving them. I'm not moving them. I'm moving backwards myself, however. So, as long as I keep pushing and they're not moving, the force of static friction, the force that's opposing my motion, is equal to the force I'm applying. It's just the opposite direction. That all seems okay with you? Fantastic. Now, once we get something moving, now we're in the realm of kinetic friction. Kinetic is in motion, obviously. And you know that it's, intuitively, you all know that it's easier to keep something moving than it is to get it moving initially, right? You're shoving something, like the car out of the snowbank or whatever else, it's easier to keep it moving than it is to get it moving initially. That F sub S max is your maximum force of static friction. That's the point at which whatever it is starts to move. And once your force applied exceeds that, then you've got kinetic friction. Net external force can be used to calculate kinetic friction. So if we've got a net force and we have an applied force, the difference between those two things is going to be the kinetic friction. Seems reasonable, right? All right. In general, again, you know this conceptually, static friction is bigger than kinetic. Friction is dependent on the quality of the surface, and you know this intuitively too. If I give you a box full of lead bricks, and I ask you to push it someplace, would you rather push it over a nice smooth tiled floor or over shag carpet? You only have to push it for 3 miles. Which is going to be easier? Yeah, the nice smooth tiled floor.
Split the bricks in half.
Friction is all about the surface. And on Tuesday in your holiday friction mini lab, you're going to discover this. It's all about the surface. It's also all about the angle at which forces are being applied. So we're going to talk about this in a second too. Coefficient of static friction, that symbol in the parentheses is a mu. It's a Greek letter. Mu. Mu.
Yeah.
Like the what? No idea. Like the symbol that we use for micro, like the prefix for micro. So we have mu sub s, which would be static friction. Mu sub k is kinetic friction. And it's just a ratio of the friction to the normal force. Okay? It's a ratio of the friction to the normal force. We're going to talk about some examples of how that changes. If you know mu and you know normal force, you can figure out friction. If you know any one of those three, you can figure out the other. We're going to do some sample problems. I'm going to give you a new packet. We're also going to do some little conceptual things here.